Hello and welcome everyone. Today we're going to be talking about absolute value inequalities. So your goal after watching today's video should be able to set up and solve absolute value inequalities and also represent absolute value inequalities on a number line. So we're going to start off our example here with, I guess, a real estate home value. And if you're buying a house, some principles that you want to guide your life is to make sure that you don't have the most expensive house in a neighborhood because it's going to be really hard to sell. And also, you probably don't want to be the least expensive house in the neighborhood by a ton, too, because people might wonder, what's wrong with it? So here's my neighborhood. So it's a pretty interesting neighborhood. It was one of those like commercial developments where they built literally 99 houses very close to each other all at once as like a economies of scale thing. They did it about 20 years ago. So we didn't move in 20 years ago. We moved in a little bit ago, and I think everyone's seeing these home prices are going up by quite a bit. But this is where I live, generally speaking, in this area. And you can see that because the houses are all very similar, the prices are also all very, very similar. So especially in a neighborhood like this, you don't want to have a value that's way too high or way too low, because if they all look the same, basically it's like, what's going on? Like, why is this guy 231 and this 96,000? That doesn't count because that's not actually in the neighborhood. But if there was a $96,000 house in the neighborhood, you'd be wondering, okay, why is that so much cheaper? So again, some price differences I will explain in this neighborhood is there are, a little bit of variance. There are some one-story houses versus two-story houses. There are some square footage discrepancies, or some are a little bit bigger. But for the most part, they're all within a couple hundred square feet of each other, and they all look basically the same, and they're all built at about the same time. So very standard neighborhood here. We're going to come back to this example, and you're going to see how absolute value inequalities apply to a situation where we don't want to be too big and we don't want to be too small. So definition for today is absolute value inequalities. And we define this as a representation of the distance an expression is from 0. So a couple examples of this, but the big idea is if you have something like the absolute value of x is, less than 2, basically what it's trying to say is x is less than 2 jumps from 0 in either direction. So thinking about it literally, anywhere between -2 and 2, x could be, because it's within 2 jumps from 0. So some steps for solving these, because it does get a little bit complicated, is first we have to determine, this does make a big difference. Are we looking at a greater than, or are we looking at a less than absolute value inequality? Big difference, because if we have a greater than inequality, I'm going to use that symbol for greater than, you actually have to use an or compound inequality from the other day with a positive and a negative constant. And we'll go through those steps on the next page here. If you have a less than inequality, use an and compound inequality, again with a greater than, again with a positive and a negative constant. So some steps here, this is going to guide you. I would say flip back to this page after going through the examples, and it might make a little bit more sense, these steps. But if you have these, it should put you on the right track, and it should lead you to start doing those correct first steps. So number 1, we have a less than inequality, and because of that, we're using an and inequality, and we're going to use our negative and positive 3 as our constant. Remember, with and inequalities, we just set these up like this. It's an and compound inequality with x in the center. So we have 2 inequalities here, the first of which is x is less than 3, the second of which, x is greater than -3, and the second of which is x is less than positive 3. So graphing these, starting off at -3, x is greater, and let's extend this number line to 3, which x is less than. So our solution is actually the interval from -3 to 3. And we're going to see that is where our absolute value lies. So the same thing would fly here. That's another and inequality. You would have -1, you would have +1, and you set it up like that with your x minus 2 in the middle, and then go through and solve, find your interval. Same thing here. Again, you would have your less than as it is, and then your positive over here, again with that flip sign, with your 5x plus 2 over 7. And a key thing to note about this one is it's not like automatically the negative goes on the left. You basically write it out as it is, and then you flip the sign, both the inequality and the sign of the constant, to set it up on the left side. So write it out as it is going to the right, like this, and it'll match. And then you have the opposite constant and the opposite sign on the left of it. All right, what about these greater than inequalities, though? What happens here? So in this case, following our guided notes again, and I have to look back at these to make sure I'm not making any mistakes too, because it's complicated, right? It takes a few steps. We have an or inequality. So we have an x plus 2 is greater than 4, or we have a situation where it turns into x plus 2 is less than negative 4. So again, change both of the signs here for the second interval. So still go through and solve basically the same way. X is greater than 2, and now x is less than negative 6 as our two solutions. And if we start to put these on a number line, this will probably make a little bit more sense for us. If x is bigger than 2, we're going to the right here, and if x is less than negative 6, we're going to the left. So we're trying to say this is more than 4 jumps from 0. So this is more than 4 jumps away. So it has to be, again, bigger on both sides, and again, after solving for that plus 2. So that's why it's going away, because it wants to be more than those jumps. So it's going to be big in the negative direction and big in the positive direction. As opposed to the less than, it's kind of a closed-in, smaller interval. Greater than is big, and it goes out. So let's take a look at my neighborhood again. How does this apply? So for me, we have the average value of a house in this neighborhood, which is $175,000. We have how much someone would want to buy a house for, which we don't know. And they definitely want it to be less than $25,000, which is the variance here. Less than $25,000 away from the average is a good way to say that. So basically what they're saying is they don't want it to be super expensive. They don't want it to be super cheap. They want it to be a house that they can invest in. It's going to be a good investment. They don't want to lose money over time. So taking a look, this is a less than inequality. So I'm going to set up my negative 25,000. Going to repeat my center here. Just like it is. Make sure I don't forget any zeros. And there's the setup. Okay, so you go through, you'd solve this, and you would see that your interval on a number line, because I don't have enough space, so I had to do this beforehand, so sorry. If you want to see this out, just let me know, and I can pass it along to you. But 150,000 and 200,000 is the range. So anything that's like way outside of this, as a home buyer, as a real estate agent, as a mortgage lender, I'd be like, no, I'm good. I probably don't want to spend, in the 230s for a house. But if it's like 187, that's in my range. If it's like 196, even that's in my range, right? So that's the idea, is it can set you up for success. You don't want to be too far away from an average house because there's risk. And especially with houses, we don't want to be taking those risks. So that's our idea for today. Absolute value inequalities is we're thinking about, is it less than, is it enclosed in an interval, or is it greater than, is it like really big going far away from an interval? And those are the two kind of representations we're going to see for this. And real estate is a real life example of where this is important, of where this matters. Thanks for tuning in, everybody. Don't forget to do the questions I didn't do on the other page and submit that form. Again, as always, any questions, feel free to book an appointment, reach out to me, message, email, any of those things, and I will see you in class